Welcome to The Explainer. Today we're diving into a concept that literally reframes how we think about teaching, learning, and sharing information. We spend so much time obsessing over the content we want to deliver, the facts, the formulas, the dates, the whole shebang. But what if we shifted our focus to cognitive preparation? Because the truth is, it absolutely doesn't matter how brilliant an explanation is if the listener simply isn't mentally primed to receive it. Picture this. It's a universal frustration we've all experienced or seen. You're teaching or presenting, you look out and you see a student sitting quietly, looking right at you, seemingly hanging on your every word. But then, they completely bomb the assignment or just draw a blank on the concept. Why does this happen? Well, we have to ask, is your learner actually cognitively ready? We often confuse physical presence with mental preparation. Just because someone is in the room, making eye contact, does not mean their brain is primed to process, connect, and retain new information. They might be overwhelmed, totally distracted, or missing crucial foundational knowledge. Okay, let's dive into this. Here is our roadmap for today. We'll start with 1, the invisible learning barrier. 2, defining cognitive readiness. 3, the 5 essential dimensions. 4, the 5-minute classroom routine. 5, common mistakes to avoid. And finally, 6, becoming a cognitive architect. And hey, by providing this clear agenda up front, we're actually modeling what's called motivational readiness, giving your brain a very clear cognitive destination. Section 1, the invisible learning barrier. This sets up the fundamental disconnect between what we try to teach and how students actually process it. There is a crucial paradigm shift we need to make here, especially for diverse classrooms. When a student fails a task, our traditional reflex is to view that poor performance as a sign of low ability. We kind of just assume, oh, they just aren't smart enough to get this. But the science of learning tells us a completely different story. Poor performance is frequently just a lack of readiness. A struggling student might simply have a temporarily overloaded working memory, or maybe they're just missing a key piece of prerequisite knowledge. It's not a lack of intelligence, it's a lack of cognitive readiness. Understanding this distinction changes absolutely everything about how we approach a struggling learner. Section 2, defining cognitive readiness. So let's transition into the precise definition of what this missing educational link actually is. Here is our formal definition. Cognitive readiness is the learner's mental preparedness to attend to, understand, process, connect, practice, and retain new information. And the absolutely crucial point here is that readiness is highly task-specific. You aren't just universally ready or not ready. For example, a student might be perfectly primed and ready to learn about history, but completely unready for a chemistry lesson, right? If you want a student to balance chemical equations, they absolutely must understand atoms and molecules first. If that prerequisite knowledge isn't there, they are simply not cognitively ready for the new task. Think of it like a giant puzzle, or better yet, the readiness equation. For a learner to successfully engage with a task, all these interacting factors must align. We need attention, because if they're distracted, literally nothing gets encoded. We need prior knowledge to connect new ideas to old ones. We've got to respect their working memory capacity so we don't accidentally overload them. We need motivation, emotional readiness, and an appropriate level of challenge. If just one of these variables drops to 0, the whole equation falls apart and learning just doesn't happen. Section 3, the 5 essential dimensions. Let's look at the blueprint of the 5 specific dimensions every teacher needs to construct a solid foundation for learning. Every teacher needs to actively manage these 5 dimensions. You need to ensure they have the knowledge, the focus, and the working memory bandwidth. But I really want to draw your attention to dimensions 4 and 5, emotional and motivational readiness. Emotion drives cognition. If you start a difficult lesson by saying most of you will probably fail this, you instantly trigger anxiety and shut down learning right then and there. Instead, an effective teacher says, this is challenging, but we will break it down into manageable steps. That creates emotional readiness. And for motivation, clarity is everything. When students know exactly what they're expected to achieve, they are infinitely more motivated to put in the actual cognitive effort. Now, what's really interesting about this slide is how we put this theory into practice. Imagine a grade 8 science teacher introducing the concept of density. The traditional way is to just write the formula. Density equals mass divided by volume, straight on the board. Boring. But a teacher focusing on cognitive readiness starts with a question like this. Why does a huge steel ship float while a small steel nail sinks? By starting with the ship and the nail, the teacher first activates prior knowledge and generates massive curiosity. Next, they demonstrate the concept with physical objects to focus attention and build conceptual connections.
Only after all of that is done, after the mind is completely primed and working memory isn't totally overloaded, do they introduce the formal mathematical formula. That, my friends, is cognitive readiness in action.
Section 4, the 5-minute classroom routine. Let's move from learning theory to a highly actionable, time-based framework you can implement at the start of any lesson. Look, assessing readiness shouldn't require a lengthy, stressful examination. Check out this simple routine. Minute 1, connect. Use a hook or real-life problem to grab their interest. Moving to minute 2, retrieve prior knowledge with a couple of quick questions. Minute 3 is for diagnosing, using many whiteboards or quick polls to spot any lingering misconceptions. Then, in minute 4, orient the students by sharing clear learning goals so they know the destination. Finally, minute 5, launch into the new instruction. Based on what you see during that diagnostic minute, you can instantly decide, are we ready to proceed or do we need a quick review? It's incredibly efficient. Section 5, common mistakes to avoid. Let's pivot and highlight the typical instructional pitfalls that inadvertently sabotage cognitive readiness. We've got some very common habits we need to unlearn here. For instance, starting content immediately. We just learned that's a recipe for disaster if students lack prerequisite knowledge. Instead, do a short diagnostic activity to warm up their brains. Another huge mistake is assuming silence means learning. No way. Just because the room is quiet doesn't mean cognitive engagement is actually happening. You must systematically check for understanding. And finally, giving too many instructions at once completely overloads a student's working memory. A much better approach is to break those instructions down into smaller, highly manageable chunks. Section 6, becoming a cognitive architect. This brings us to the ultimate paradigm shift, moving from being a simple content deliverer to a designer of learning environments. Let's move to and see how this builds across Bloom's taxonomy. I want to be very clear about something. Creating cognitive readiness does not mean making learning easy, not at all. It's about establishing the right foundational knowledge so you can safely and effectively increase the cognitive demand. You start with recall and understanding, ensuring the readiness is firmly there, so that you can confidently push your learners up this ladder to apply, analyze, evaluate, and ultimately create. It's about appropriate challenge, not low challenge. This quote absolutely hits the nail on the head. Good teaching is partly the deliberate management of students' cognitive conditions for learning. That's the central thesis of our explainer today. You are a designer of learning environments. Your primary job is to architect the mental conditions, managing cognitive load, capturing their attention, building their confidence, where meaningful, deep learning can actually take root. So I want to leave you with a final provocative thought. Before you ever ask yourself, what should I teach today? I want you to ask yourself, what must be happening in my students' minds for this learning to be successful? When you start answering that question, you unlock the true potential of every learner in your room. Thank you so much for joining me on this explainer. Keep designing those incredible learning environments, and we'll catch you next time.